Okay, everybody, like a real recap on today's lesson. It's lesson 2-1, I think, page 333. So here's the deal. We have a club where there happens to be 324 total people. In the club, there's teenagers and adults. So the total of teenagers plus adults is 324. But the teenagers outnumber the adults. So teenagers, if you subtract adults, is 34. So what you see is two different equations, right? Well, one way to solve these is by a thing called substitution method, right? So we wrote both equations down. I solved for t. I brought the a over. And then I can substitute in the t and get an equation. So then if you look at the next page, that's exactly what they do. You see the two equations. They brought this one over. They've got y equals x equals y plus 34, and they plugged that in for x, and they were able to solve it and get 145. Then, if you knew 145 in this case, it had to be my adults. They plugged that back in for y, and you end up with 179. That's one way to do it. Now, I thought an easier way to do it is just by the elimination method. Much easier if you just add them, because I can see if I add them straight down, what happens? The y's cancel. So I notice y and a minus 1. If I add, I get a 2x. The y's cancel. I can solve for x, and then I can substitute it back in. 179 goes back in for x, and I get y. Now, that's kind of a quick lesson. So what I did is a worksheet on this. So let me show you the worksheet I did on this. So I did a whole worksheet on the substitution method, okay? So in this example, since they both equal y, I set them both equal to each other. I mean, x plus 3 is equal to y. So instead of writing y, I wrote x plus 3. So I just did a substitution. I put this right in here for my y, okay? And then I solved, and I got x equals negative 1 after I solved it. And then I'm able to plug the negative 1 in for x into either one of these. That was probably the easier equation, plugged it in for x, and I got 2. So what we have is really, even though we never graphed them, it's basically two equations that intersect, and what happens is they intersect in a point at negative 1, 2, okay? We just didn't graph it. It's easier to do without it. Okay, problem number 2, I did the same thing by substitution. I like to set them side by side, take the two equations, write them side by side. It's much easier. And then I saw that y was equal to 5x plus 5, so I plugged, instead of writing y, I substitute, don't write y, but substitute what y is equal to, which is equal to my 5x plus 5. Okay, now I can solve for x. So I get a 6x plus 5, because I added the x's, minus 5 minus 5, I get negative 12. Divide by 6, I get negative 2. So then, because I have them side by side, I wrote, since x is negative 2, instead of writing x in the other equation, I write negative 2. Let's go back to my other equation, and I get negative 10 plus 5. I get x equals negative 5, and again, the answer is a point. X first, x, y, negative 2, 5. Okay, then on the next page, same thing. Again, if it's substitution, I write them side by side. I have already x by itself. It says x is equal to y minus 6y minus 1. So instead of writing x, I write what x is equal to, 6y minus 1. And then I want to solve for x. So I distributed 24 minus 4, 25y, because I added those two x's, plus 4, 1, divided by 25, and I get 1/25, or 0.04. Now, this is a great example of why we don't want to graph these, because you're never going to get that answer by graphing. I substitute that back into the other equation. That's what y is equal to, so write that instead of y. And I solved it, and I got a negative 0.76. So, great example of why graphing won't work. You're never going to get this answer by graphing, only by algebra. Okay, example 4. What I notice in this elimination is, so let's do this one differently. I see this. I see, if they're lined up like this, my y's, my negative y's, those will cancel each other out. I'm left with a 5y equals 35. It's nice because boom, 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 cancel, cancel. Solve, divide by 5, get 7. So now you do have to substitute in to get the other y value. So I took equation 1, and I plugged in equation 1. Okay, so plugged it right in there, and then I solved it, and I got negative 4. Okay, and that is my answer. Okay, that's all I have. Hello?
Hey Bill, this is Sean Recruiter.
Oh, Sean, how are you, bud?
Not bad, just working away in the snow.
Oh,